Anyways, hey all, welcome to awesome LangChain AIMUG, AI Middleware User Group. How many people we have here? A lot. So good to see so many faces here. What's on today's agenda here is we're getting some intros. Who here is new to LangChain and new to the group? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Well, welcome. It's good to see new faces and great to see so many returning faces here. So we're going to do some intros. I'm going to give an update on LangChain 1.0 and LangGraph 1.0, which means we're moving to a non-breaking, production-ready LangChain and LangGraph. Really, really cool. I'm also going to give some feedback from a meeting that I had with Harrison and team last Wednesday and some color inside that. Then we're going to continue on to some talks and demos. Sal, you are right there. Sal's going to talk about Claude code and custom agents. We're then going to switch to Collier. Are you ready to talk about deep agents? Awesome. James, are you here? Right there, cool. Awesome. James, you're going to talk about Rosie the robot and an application you made. James is also recording podcast interviews with the After Party. Awesome. And then Jeff Linwood is right there. I think you got Streamlit dashboards with some LangChain and LangGraph integration. If this should be a really packed schedule, can someone volunteer to be a timer and keep things to 15 minutes? Anyone? You got a clock? Okay, thank you, Ryan. Okay, after that, we're going to try wrap up around 8 to be cognizant of our interns that help us so nicely here. And then we're going to roll on down around the corner to the Tavern, which is like the oldest air conditioning in Austin. They have cold beer, some non-alcoholic stuff you want, great hot wings and burgers. And podcast interviews James is recording. Okay, for those that are new, if you go to aimug.org and click Learn, we try to consolidate our documents there and our learnings, right? Sometimes we're good at updating them, sometimes we're not. All the links and the references for my talk are up there already. But there's also, if you want to join our Discord, you want to get on our mailing list, you want to see our events, it's all up there, aimug.org. Want to thank our founding members, and we're member supported and corporate underwritten, right, just like PBS. Our members, just like you, allow us to have some intellectual honesty and drive our own direction. Our corporate underwriters are the Center for Government and Civic Service, where we're in here today. They support us on our space and with our interns. LangChain AI, which has been supporting us for the past 2 years now. Always Cool Brands, which is my company, the company I work for. And then Toolhouse. Who here knows Orly? If you don't know Orly, you will get to know Orly. You probably see one of his rants. He's a really smart guy, does a lot with, who here knows MCPs? Oh yeah, Orly was one of like early on MCPs with us. So for me, my name's Colin McNamara. I do not work for LangChain or LangChain AI. I'm a local entrepreneur. I'm the co-founder of Always Cool Brands. We make products that go into grocery stores, and specifically we take the poison out of it, or things that we believe are poison, things that may give yourself cancer, make your kids stupid, reformulate with something that won't kill you, put it back on shelf. We have 19 products coming into the retail supply chain under a number of retailer brands, Q3 and Q4. We use LangChain and LangGraph in 2 of our 8 applications, as well as LangGraph in a 9th one. And so I am a user of this technology. I'm also the founder of this group. I used to call myself a 10% developer. I now call myself a 50% developer. I know, Baskin's laughing. Baskin, I'm like, man, I just struggle to pick this stuff up. I'm like, what the heck? I'm a reform manager. Like 3 years ago, I left high tech. I was a service owner at OCI. I had networking globally for optical, and then Indian networking for all the platforms that powered the White House, the NSA, or sorry, not the NSA for that one. Those are different ones. The White House, all the SaaS platforms, every bank. I had all those networks end-to-end, as well as wireless in every platform globally. I said, screw that 3 years ago. I wanted to use my time, my brains, my effort to make the world a better place. And so I left that to do stuff like this. But now, I'm a reformed manager. And so I had to pick, I said, I want to be useful again. And so I started learning programming again. I found LangChain. I found Harrison's Chat with Data Challenge. And long story short, his little RAG notebook saved me from an SEC violation and found fraud in my supply chain. I said, I need to find other nerds like me. And I started finding people, and here we are, 1,500 people. So I'm just happy to be here. Who we are, that's actually 1,500 now. We have 1,500 some members of Austin LangChain. AIMUG, we just learn in the open. There is nothing that anyone is here to sell you. If someone is trying to sell something on stage, it means I have to cut it out of our videos before it goes on public television. So like, please be, you can be proud of your project. It's okay, but don't buy this now, call to actions. Well, we don't do that. But what we do is we show our work. We're like, I'm really proud of this cool thing that it does. I'm really proud of the company I work for, right? I'm really proud of the tech that we make. Here's the tech that it works. And we do that, we will do that on brand new technology that maybe came out this week. And we teach it back to ourselves, right? So that is key to, wrong way, to us learning in the open. So we only have 2 rules that we follow here. One is be cool to each other. So I know when I'm learning, I'm like a kindergartner. When I'm really learning something I don't know, when I feel all that insecurity, where there's nothing I know that is making this work, I feel like crap. I feel like a little kid. And everyone feels like that. And so if a little kid was presenting up on stage, would you rip them apart? Would you do the nerd thing? No. You'd be cool to them. So we're cool to each other. And then we're not gross. We all know grosses don't do that. We haven't had a problem with any of that. So all levels are welcome, whether you're just a community college student, whether you're an AI researcher, everyone in between. And us teaching back to each other has created this flywheel that we are ahead of the curve. We have Silicon Valley execution and patterns here in Austin that we're all practicing, and it's due to every single one of you. For those that are new and need to be reminded, where and when we meet. Normally we meet on the first Wednesday here at the Center for Government and Civic Service. We do showcases, we present back to each other, we have a little mixer, and we go over to the bar afterwards. Normally we have either a hacky hour where we go out on town, hack on our laptops, hang out, grab a beer, or sometimes we'll go over to like go and brigade another event in town, right? And then we have office hours at 5 p.m. on Tuesdays that are open. What's up, JVL? So we have office hours at 5 o'clock on Tuesdays, and who here is normally on office hours? It's about 10 people, yeah, most of the time. We had 10 people on last time. It's really, really great. It allows personally me to checkpoint what I'm doing, and for others to checkpoint what they're doing, to get quick feedback, and it's been one of these really, really cool tools. I encourage you to drop in where you feel comfortable, and you are always welcome no matter where we are. So for those that are new, what the fuck is LangChain? Right? So LangChain itself, and we say LangChain AI is a company. What's Paul saying? Might be a setting on a Zoom. Yeah. Oh, the videos, whatever. Technology, that's not good. Can you turn on and off the, what you call it, the picture-in-picture? Either way, pop it back on, right? Okay, cool, no worries. So we're just gonna keep talking. So what the heck's LangChain? So LangChain AI is a company. They have 2 open source projects, LangChain and LangGraph, and also deep agents now, 3 of them. Specifically, these are open source projects that are in Python and in TypeScript that you can both build an AI agent on, just like you can do Pedantic AI or OpenAI, you can do LangChain AI, and I'll talk just after this about the 1.0 and why that's simplified. And then you have LangGraph, which allows you to effectively do a multi-step graph of your AI agents in groups of agents and say how the groups of agents will work together. It is really cool. There are commercial platforms that you can use. There's LangSmith that you use for tracing. I use LangSmith as well as a number of other tools. And there's LangGraph platform. I'm a believer, like if you use an open source project and they have a way that they commercialize, throw them a couple coins for how they commercialize. It works out well. That is basically my LangSmith usage. And then, that's what they got. So we talked about the talks and demos today. I'm going to give a LangChain 1.0 update. Again, we're going to do Sal for Claude Code, Collier for deep agents, James for Rosie Robot, and then Jeff for Linwood for Streamlit. And on that note, I'm going to give an update for LangChain LangGraph 1.0. So who heard the news that 1.0 alpha is out? 1, 2. Okay, so for those that haven't heard, LangChain and LangGraph 1.0 alpha is out, right? So we're targeting late October for the full 1.0 release. So we got about 30 days, right? The APIs are in flux, the docs are updated, so it's about time to start playing. The good thing is for LangGraph, there's not really many changes, right? At all. LangChain, they are. So the big picture in one slide is LangChain 1.0 alpha has shifted from the LangChain we started with 2 years ago, evolved over 2 years. It started as a way to abstract between like OpenAI and other models. It started as a way to chain prompts together, hence LangChain. It evolved into this LangChain expression language, which got kind of weird, and then kind of grew into, the reason it became so popular, it was the one place before MCP where you could integrate in all these different AI tool chains together. Harrison was really good about let anyone merge into that. It was not stable, but it was useful, right? So LangChain 1.0 has changed into 10 lines you can create an agent. It is functionally the same as OpenAI's agents or the Pydantic SDK. If you look at it, functionally the same, right? LangGraph 1.0 is the same LangGraph. And who's been using LangGraph? Okay, about a third of the room. There's almost no changes in your current LangGraph implementation. It's just now going to be non-breaking. Durable execution, streaming, human in the loop, time travel, all there, right? So a lot of things that if you're developing in if you're developing your own, rolling your own code or whatever, you can go ahead and handle inside there. LangChain core, right? One really interesting thing, did anyone see the notes about standard messaging content? So the level of abstraction has moved up a little higher now that in LangChain core, in that there's basically a middleware between your message blocks, right? So you don't have to have everything crafted so specifically to each of your providers. And then the docs actually got updated and they're not horrible. So the mental model for those that are new is LangGraph is like a runtime orchestration engine, right? It's a way that you can basically define your nodes and your edges together and say, step 1 goes to step 2, goes to step 3, goes to step 4. I can make sure that each step that there's a save point, there's a checkpoint in that. I can go ahead and roll back my agent into a previous step. I can, if I'm running my agent on like Cloud Run or something, and it drops, since the agent itself can save state to a Postgres database externally, I have state, I can respawn. It is really great. It also allows you to externalize the human in the loop and the interrupts. So if you have an approval process, right, that you can pop into your agent in using LangGraph, you can pop in and do a human in the loop. You can pause the execution and pop it either to the human that's running it or externally. LangChain itself is basically like getting started. Any one of you can pull 10 lines of code and have an agent. And functionally what happened is the old LangChain that we used for 2 years is now basically a classic. And you can still use it, it's just got to import different libraries. The LangGraph agent is now LangChain. So it is a complete rewrite and on with modern times. And if anyone's used Deep Agents, has anyone used Deep Agents yet? Anyone use Claude Code? Okay, that same pattern used in Claude Code, you can use in Deep. You can build that in a Deep Agent, and Collier is going to talk about that. So LangChain agent runs on LangGraph, is 10 lines to start, and is really easy to prototype, especially if you're using agentic development, right? So if you're using like Claude Code or Codex or Yo, what's up?
So just to clarify, how would you enter LangGraph or LangChain going forward? With the original LangChain core, so that it looked like here's some documents or some JSONs. I'm going to ask you a question. What is the answer? Is that changing with the core?
It'll still work. Just the fundamental code base has changed. Okay. Yeah. It's just a single agent definition. And you can also roll in if you have ADK as your preferred development kit. You can roll ADK inside what's called Google's ADK. Google's agent development kit. You can run that in LangGraph. You can run small. It's basically just like an underlay that you can use for agent execution. And then your LangChain agent itself is just much smaller.
Okay, so you're just basically swapping out what's under the hood, but the interface for it, that's not.
Correct. Yeah. Yeah. And now will be non-breaking from now on, which is cool. So when we talked about specifically to answer your question for 1.0 alpha, it's a one agent abstraction, right? So create agent or create agents is now is on LangGraph, right? The content blocks. This is a thing that just came out like I'm not sure if it came out. I think Harrison said he was going to post. I think he posted the blog post on it. But the standardized content blocks are like your inputs and your outputs. If you switch between like OpenAI and Anthropic and another model, sometimes it shows differently in the logs for sure, right? But now you can go ahead and you can standardize the blocks no matter what your model is on the back end. So it's a lot easier to switch models. And the old stuff has moved to LangChain Legacy. So if you still want to use your any old LangChain code, you can use it. It's just in Legacy. LangGraph is, from what Harrison's told me, is there's not a lot of changes, right? There's small cleanups, right? Basically there's the core runtime is unchanged. So LangGraph has been stable. It's been working. I use it in 3 apps right now. 1 LangGraph Python, 2 in TypeScript. I'll wait till production to go into production on it, but I'm going to bring it up in the lab and be ready for it. So for the big thing that you get with LangGraph right now is because it's managing the state of your agents, you can have you can depend on LangGraph to manage that state, to checkpoint that state, to roll back the state, and to be able to handle that externally. So it just handles that without you handling it. It handles the human in the loop, which who is using human in the loop in their workflows right now? Collier, Sal, Dimitri, a couple others. So it is, that's kind of an important thing, right? Especially if you're going to do any sort of financial transactions or like, I don't know, maybe within about 60 days I'll have it doing in my approval stream for EDI transactions. I mean, some of those orders are a couple $100,000, so we'll see. The other things is time travel, so you can go back and forth within your agents. Streaming modes, so there's 4 modes that you can do now. So there's messages, which is a token stream with metadata, so chat. There's an updates streaming modes, which will update your UX, right? You can pass values, which is a full state snapshot, and then you can customize it so you can debug it, right? The time travel itself, right, is persistence and time travel, right? So you have checkpointers, which is the most important thing, right? So you can checkpoint each step in the thread, right? You can basically do, when you're using LangGraph Dev, for your local development, if you use LangGraph Dev, you can serve checkpointing there. If you're doing things in a more web scale way, you can export it to Postgres, which is really quick, really cool. And I talked about this earlier about the time travel, is that you can move to any earlier step in your workflow, right? So you can go backwards, you can modify that state and roll forward. So instead of having to like rerun an entire job, maybe you did a lot of data ingest, right? You can move backwards to a failed state and retry, and you can fork from there. Kind of neat. For human in the loop, right? So when this is with LangGraph, you have your interrupt, right? So you can persistently interrupt the state, right? You can just leave it sitting. And remember, if you're running this either on LangGraph platform, which they may call Langsmith platform or LangChain platform, they're kind of deciding that right now. Or if you're running it on your own systems, right? Pop that state to a Postgres server, and it's there as long as your database doesn't screw up, right? You can go ahead and resume it after it's been routed appropriately to the appropriate person. You can make sure that when a tool call happens, you can do before and after tool calls. So you're like, I called the tool, it's coming back. Was my response good? Do we want to move forward? And then you can have critical approval checkpoints, which is really cool. The standard content blocks we talked about at View, which is So just normalizing across OpenAI, Anthropic, and others, right? And all your reasoning, all your citations, all your tools, but also your multimodal inputs. I think it's kind of cool. And supposedly the whole idea here is like, just like we started 2 years ago with LangChain, is it makes it easier to switch between providers. Dimitri, do you have something to say about it? Yeah?
I'd say that's the area that I'm starting to get tripped up a lot now, because like I'm finding that now like the best model is so task specific now.
Mm-hmm.
Like some of the 7 billion LLMs are very good at
Yeah.
subdivision tasks.
Yeah.
And my thing before was like you run with Hugging Face and you try to use like with structured content, it just works.
Yeah.
Or once upon a time you're like, oh, I want to go from like Anthropic to OpenAI, but forget it.
Yeah.
Or you had to like rewrite half of LangChain
Mm-hmm.
to then like, especially like LangGraph, you're saying you have a LangGraph call, but then inside it you're like, okay, I have OpenAI, I have Anthropic, they look the same. I have this Hugging Face thing that is this custom thing, probably doesn't use half of what the LangChain classes are expecting, and then that just like leads you to a world of pain. You're just like, well, what am I even doing with this?
Well, I think a lot of us are both experiencing that in multiple ways, right? So I know for me, for my my meeting notes application, right? So I have all my meeting notes, my transcriptions get enriched usually at the end of the day using a stupid Python script running LangGraph. And it started with Sonnet 4 to do it, and then I was like, oh, well, what's the most efficient way of doing it? Because I'm a nerd. And that runs on, I ended up making my way down to Llama 3 8 billion parameters, right? And to be able to dynamic, and who here has gotten pissed off at Claude Code for a moment and switched over to Codex or whatever? It all happens, right? We can do that with by switching to a new CLI terminal, but the reality is when we do long-running jobs, we're probably going to have them defined as an agent. And being able to swap those transparently, pretty important, I think. So for those that are moving to 1.0 alpha, heads up, Python minimum bounced up from 3.9 to 3.10. So you're going to have to run that. And for us, I think I might actually have to update my Node.js. I'll have to take a look at it. But 20 is the minimum. So for people that are defining what to build, right? So if you're new, the default path, start with LangChain agent. It's already in LangGraph, right? It's basically the LangGraph small agent inside of there. For your runtime design, right? You can choose your modes, define thread idle, or pick a checkpointer, right? If you're running local, you can use SQLite as a checkpointer. But if you have the opportunity to throw in like a Postgres database, you can get something that's more production ready. And then, if you are a Postgres user, most Postgres implementations support PG vector, and so now you have a database ready that if you want to build a RAG or a graph RAG or mess with any of that, it's all ready to go. And you can think about, I don't know, any of the hosted models are generally going to allow you to not have to be in DevOps hell, right? And then the last point on your concepts is the content blocks, right? By thinking about switching into content blocks, it's putting a layer of abstraction that allows us to switch models, right? Because eventually, a lot of us have seen this, where the open source models become powerful enough, or we realize we can focus our agents down, right? So for those that are new to LangChain, so proof that these runtimes, specifically LangGraph, are production grade. Yes, Nate?
Sorry, on that last slide, you mentioned streaming modes a couple of times. Could you give maybe just a couple of examples of like what you would use in a different streaming mode?
Yeah, so if you're doing a dashboard update, and I'm still I'm deep diving on this too, so I'm sharing as I'm learning it. From what I understand, there's like if you want more of a chat interface, there's the messages, right? And let me go back to the screen that has the list. Human loop, standard content blocks, streaming modes. Okay, so like updates, for example, that is good for dashboards, right? So if you have a dashboard and you want to pass information that dashboard, like say maybe you're using like Vue and Grid 2 or something, and you want to update elements in that dashboard, you can pass that back up in the updates mode, which I think is going to batch update. I need to debug it to see exactly how it's doing it, but like that's great for a dashboard, right? So messages, chat interface. I haven't played with values in the debug, so.
Okay, so like so messages then would be just your normal like every
stream, yeah.
Back and forth, but then if you're doing updates, it may not do it. You may have 5 or 6 back and forth, so it may not do a notification. It's helpful.
Yeah, it's more of a batch.
So it's based on whatever the snake chain or like whatever the.
As I understand it, yeah. And and again, 1.0 alpha, let's turn and burn. Let's like try it out and get some feedback. I'm looking to learn too. As I say, I am not the expert here.
It's like the note at the bottom plans latency, control the latency depending on the use case.
Sorry, what?
You can control the latency depending on the use case.
Perceived latency, yeah. Which is kind of cool. Let me see. Yeah, this is a really good hour-long call with the LangChain team and a few other like power users. I like to share what I learned. I don't sure I understand it all, but I'm learning right now. So for those that are curious, there are people that are big time using LangGraph in production. Uber is, LinkedIn is, Klarna is, LangChain AI is, Always Cool Brands use it in production. Right now, I use it. JP Morgan Chase, Nova Bank. Anyone other big ones I'm thinking about? Collier's, Cloudflare use it? Yeah, at least one person at Cloudflare uses it. Yeah, so no, it's there. So for the anti-patterns to avoid, right? So single function agents, right? So push things into graphs. I've started writing my test harnesses in LangGraph. It's just really simple. Each of the tests drive in my graphs. I have an entrance agent, and then each test is a node on the graph, right? And it logs beautifully, so beautifully. I can go into LangSmith or LangFuse from running locally, and I get like exact breakdown of what my agents were doing, right? And what the results were. It's really, really great. Other anti-pattern is token-only streaming. Next one is ephemeral memory, right? So if you're keeping your memory in your agent, like and you expect things to stay around, like externalize it, find some sort of Postgres database to stuff it in, right? You can go to like, that's like, I don't know, $20 a month to throw one up. It's nothing. And then provider-specific parsing. I think a lot of us have learned over the past 2 years, being locked into one provider makes it so we're not doing the cool stuff. Okay, so other things, all of us have complained endlessly about docs. We spent the first year here writing training just to train ourselves up on it because the docs sucked, right? So check out the 1.0 alpha doc site. It's really, really simplified. So Python and JavaScript are together. You can switch between them. There's guides for most things. They Harrison hired in like 3 new people for docs. So he's actually putting his money behind it. So the integration docs are prioritized. And then one thing which was a feedback we've all given was it's great to have a notebook, but actually give me a template how to use this damn thing in production, right? So check out the doc site. We might find those there. Pretty cool. Other things, this came out of the call, so this isn't published yet, but this is kind of forward-looking what Harrison's thinking of. So just like with deep agents, Harrison was like, oh, there's this new pattern we're all using with Claude. We're basically using text files as shared memory back and forth. And for agent definitions, this is a really easy, quick way of hacking things together. And so he hacked together deep agents that leverage all the LangGraph stuff. So deep agents is an expand 10% deep agents, 90% LangGraph. You can do things like that on it, right? So other things are insight clusters and custom behaviors are looking at basically figuring out different, taking different insights and clustering behaviors and have that reflected in the agents. So other things are looking on the forward-looking, and this is stuff where LangGraph is looking into, which is identifying and isolating failure modes. So as more things come into production. So the future monitoring hooks are more native hooks for better observability. So like right now, you can go directly into LangSmith. You can put in a SDK, throw it in LangFuse. You can hook it into OpenTelemetry. But for those of us that are looking at our entire application stack, what are we doing? Datadog, Signaws, right? Maybe we're running Keep. I don't know if anyone using these things I talked about. You should probably check them out. They're really, really cool. And then other things that are expanding into is being able to drill all the way down. And a lot of this is coming from just like the production level insights around this. Let me see. So for anyone that is curious about learning more, there's key resources here. This is on, if you go to AIMUG.org, hit learn, go to September. All these links are there, so if you want to drill down. This presentation's up there too. I think it's linked in. On that note, I want to hand it over to Sal. Yes, sir.
How does LangChain compare to Strings SDK?
Huh?
How does LangChain compare to Strings SDK?
Strains SDK? I haven't used Strains SDK. What's your thought?
I haven't used LangChain.
So LangChain itself, and you might have came in a little late, was like a 2-year-old project, one of the early integration points. We've had all of our pains and joys and hates and loves about it. Functionally what's happened with LangChain 1.0 is they took the agent inside of LangGraph and did a complete, and just pulled that in LangChain. So functionally, if you're using OpenAI's SDK, if you're using Pydantic's SDK, or if you're using the LangChain agent, it's almost looks completely the same and acts completely the same. That's the function. I don't know about Strange or anything like that. Strains.
Open source.
And the thing is, there's like 1 billion of them, and you can put them inside a LangGraph. So you can use LangGraph to orchestrate whatever. Because what is the reality? We run things in production. Like not all my agents are LangChain or LangGraph. So a lot of them are native OpenAI and Next.js, but I can run them inside LangGraph if I want. On that note, Sal, you want to hop up here? Sal's going to go ahead and talk to us about Claude Code, custom agents.
Yeah, so I'm just going to do a little presentation on Claude Code, kind of the development of our agentic coding tools, mostly terminal-based, but kind of just speak to some more generalities there too. Start off, does anybody use Claude Code like on a day-to-day, or maybe any other like agentic terminal-based, like Codex or what is it, Gemini CLI? That's another one. I've never tried that one, to be honest. But yeah, so hopefully this will be relevant to most people here, and you don't necessarily have to be a programmer nowadays to get advantage, take advantage of a lot of these tools. So that's pretty cool. Let's go. Where are we? Ah, nice. So I'm just going to do a brief history lesson. I'll speed through it. It won't be too boring if you're really into it. You probably know most of this stuff already, but so kind of at the beginning, the dark ages, when ChatGPT first came out, like late 2022, the whole big craze was prompt engineering, right? So everyone wanted to like craft the perfect prompt that would instantly get their result right away. It's funny looking back at it now. I mean, we could laugh at it and be like, well, it's not really how you do it. It's kind of more of like this iterative approach, right? But back then, I don't think that was as obvious. But we discovered like a lot of patterns to like kind of like coax these responses out of LLMs that took a lot of time to generate, and then we found that they weren't really like easily like generalized to other language models because they had their own kind of quirks and intricacies to them. And kind of like newer models came along that tried to solve these issues, but it still was like relatively inefficient, especially compared to the tooling that we have now, particularly when it comes to code generation. Seems to be one of the things that it's actually quite good at. So yeah, this stuff is old news. We don't have to worry about it anymore. So kind of the new space we're in now is the context engineering. So we have this MCP and kind of all of these tools that we can provide to the model to get more accurate and useful responses. Especially with a lot of the tooling that we have now, it's kind of like we're building a scaffolding around the foundational model. So like Claude Code is a good example. You have, you can even select different models, right? So I don't think you can choose Haiku directly, but you can do Sonnet and Opus, and then depending on your limits, you might get cut off from Opus. But got to shell out $200 a month to use that, right? And then, they degrade it too, so who knows? But yeah, so one way that tools like Claude Code kind of address the main issue with LLMs, right, is that they're kind of ephemeral, like transient. You don't have a memory to these LLMs. They're stateless, almost like, if you're a developer, like a REST API, right? It's supposed to be that you don't keep any session information in the model itself. All you really have is the context window, right? And then once the context window either gets compacted, so kind of like summarized, or it gets cleared out, you don't have any relevant information kind of from, or as rich of relevant information in the case of you compacted it as you had previously. So we, as Colin had mentioned kind of in his presentation, one of the ways that these coding tools are addressing this issue is creating instructions files like your Claude MD and kind of things like that. So you have information in a LLM-friendly format, and it allows you to save state in between request and request, and even when you compact or clear out your context window. So that's, and then I would argue, one of the main draws of these terminal-based agentic coding tools, rather than maybe like a Cursor or a Copilot, is I think it's a general consensus that you have much greater control over the context that you provide to your foundational model. So you can compact and clear whenever you want. You even have like nifty little commands like /context to actually see kind of what's loaded into the context. So you really, I think, have like much greater observability into it. But the main issue with this context engineering, the thing that you're fighting against is finding the happy path between providing enough context to your LLM to get the task done while not overloading the context and kind of poisoning it or confusing the LLM with too many potential options. So that's kind of where we get this idea of context engineering from. And kind of moving on, one of the ways that Claude Code in particular, and it seems like it's also being generalized in deep agents, to address this context issue is the idea of like these custom sub-agents. And then Claude Code has had this ability, pretty much since it came out with the task command, where you could see that it would run separate tasks, maybe a bash command, or it would reach out to the internet with the web web request tool. But you could also ask it specifically to create a bunch of different like role-based sub-agents is what they call them, and you could either run them in parallel or serially, and they would all kind of go off and do their own thing. But the main advantage of them is that they had their own context windows. They would receive a prompt from the orchestrating agent and then go and do its task, summarize its findings, and then return all of this information back to the orchestrating agent that could then load these summaries into its own context and make a generalized like assessment, or in Claude Code a lot of the times I would use it for researching, and then it would add it to the plan. So you could have a plan with maybe a bit more information out there kind of observed from many different roles or perspectives. And now, I'd say it's been 2 or 3 months ago, Claude Code released a new feature, Anthropic released a new feature in Claude Code rather, called custom agents, where you have predefined sub-agents that have their own prompts, system prompts. They don't inherit from the Claude MD, so they kind of have their own, they are influenced by what the orchestrating agent is. So it kind of has that isolation, right? It's able to kind of complete its task without having to rely on an agent to, the orchestrating agent to make the choices for you. Hopefully we can sort that noise out. Anyway, so yeah, this tool is pretty great. Now they do require setup using the /agents command, and you can then define the system prompt or kind of have Claude do it itself, a Sonnet or Opus. And they're much more customizable also. You can choose the tools that they have access to, including MCP servers. So that's another really good advantage of it. And since they're defined in Markdown files, they are transportable. You can move them between projects. So you have like domain-specific work, and if you, as long as you have a good description of these tools, the orchestrating agent can actually call them. Yeah? Yeah. For sure. Yeah, definitely. So kind of moving on. Here's kind of an example of what you can use. Loud enough for you, or still can't hear me? Yeah. Can't speak too loud, then you echo, all right? Okay, thank you. So here's an example of a custom agent that is a code reviewer. So you kind of have an example of the Markdown file that would define the way that this agent works, and you can choose the model and the tools that go along with it. This one in particular, you even define like when it runs. So general guidelines is you kind of want to keep like one job per agent. You want to restrict the tools, kind of start like read only, and then introduce editing tools as kind of that functionality is necessary. And that also helps you keeping the context small and focused and returning actual like useful information. And then of course using clear and specific descriptions so that the main Claude code knows when to invoke these agents. So we've got a couple of examples, kind of code review, QA, debugging. These are all like kind of software development lifecycle specific. Yeah, question?
Yeah, so Claude Code has a bunch of sub-agents that it uses already.
It can, if you prompt it in such a way, it will make them kind of on the fly. Is it 15 minutes or 10?
You're at 10 right now.
Okay, yeah. Go on.
Are there also people who have created ones that, like is there a library or repository somewhere where you can access?
Yeah, there's definitely repositories out there. I've seen quite a few. I don't have any offhand, but you can definitely look them up and find them. There are some downsides to that I'll kind of get to in the later on slides. Let's move on here. So here's kind of an example of kind of some of the cool stuff you can do with sub-agents. So you can actually run them in parallel and define an execution plan where you have your custom agents move from phase to phase to phase and then run your sub-agents all at the same time, assuming that the tasks that they do can be parallelized. They don't rely on they don't rely on resources that they kind of need to share between them. So I was working on making a new personal site that had a blog in Astro. So I actually had Opus create these sub-agents for me, particularly for this project. And then I took a few like GIFs here, some videos of kind of that parallel action working. So this is kind of the stuff that kind of makes you feel really powerful is you have all of these little tiny processes running at the same time to accomplish some pretty cool tasks for you. So just a little example of some of the cool things that you can do. And this top picture here is actually the Claude MD that kind of outlines how you would use these tools. So you can either have that or create like a plan in plan mode if you want to kind of invoke the agents in a serial way where it passes the information from one to another to another. So and then this is just kind of a closeout here. I've kind of spoken about a lot of the upsides and the advantages of using these, but there are some downsides. So all of these agents cost context space. They are tokens, as you can see there if you list them out, and you hit /context and you can see what is occupying that. And the custom agents, along with your MCP tools, all contribute to you could say context pollution, but maybe context enrichment, however you want to view it. So keep that in mind. you don't really want to have like a very large amount of large sub-agents, because they will cost a lot of tokens and they will they'll eat up your context window, and then you're compacting or you're clearing out more and more often, and generally that kind of reduces the quality of the output that you get. I think that's it for me. So does anyone have any questions? I got 2 minutes for questions.
Yeah, how well do sub-agents work for multimodality? If you want a sub-agent that's very focused on, say, images or media, and really like keeping track of stuff in the image?
Yeah, I've tried out kind of something similar to that. So say you have like maybe an accessibility or kind of like a reviewing sub-agent, and say it uses like a Playwright MCP to load up like a headless Chrome and then like take a picture of a website. And then it can kind of analyze that and provide you, maybe to see like the contrast, right? Is there enough difference between these two colors on the page that it's accessible, basically. I've got mixed results, kind of with most things. I think it's like a work in progress. Although Claude Code in general is actually pretty good at images, but it kind of varies. So yeah, I'd say it's definitely something that can be improved. Yes, sir.
How do you think about one job, one agent, defining what the scope of that job is? For instance, not that many small subtasks.
Yeah, so that's kind of the name of the game, right? That's, I think, the main thing that you're thinking of when you're creating an agent. Yeah, I try to think of like kind of an atomic set of maybe transactions like in a database or something. Like if all of these maybe even smaller tasks kind of go together, that could work. So say you're creating components in a React site. Maybe you could have an agent that does that, and then maybe you have another one that does like unit testing or something like that. So, but I could chat more about this, afterwards if you'd like. But I think my time is up.
Awesome. Thank you so much, Sal.
Yeah.
I am
Everybody?
absolutely stealing this pattern from my Astro blog. Which, anyone using Astro? I think Collier. Collier is the one who started this.
Fun one.
Right?
Yeah.
Jeff. Yep,
That's where I heard it from.
It's, let me switch from my laptop. There you go.
You got HTML where you need a
Yeah, talk loud. Okay,
Yeah.
so I'm Collier King. I'm going to talk about deep agents from LangChain. So I just called this subtitle a batteries included deep research framework. Might be a little, I'm not trying to sell it or anything. I don't work for LangChain, but basically it's trying to solve this problem of the shallow agents. So you think about like the most simple agent, it's just an LN that calls tools in a loop until some conditions met. This doesn't really cut it for like complicated use cases. There's the following pain points that tend to come up over and over again: sustained context, long-term planning is tough, complex workflows are not really feasible, and then parallelization and delegation is not easy. So that begot deep agents, and that's kind of a term that turned into this package. But basically, Harrison, the genius that built LangChain, studied Claude Code very intensely, and he came up with these 4 design components that Claude Code implements very well. And he tried to distill those into an easy-to-use Python package, and he called it deep agents. And so those 4 components are listed here, and I'm going to go through those in a second. So, like I said, it's a Python package inspired by Claude Code. It's all LangGraph under the hood, so it's kind of building on the existing success of LangGraph. You might recognize some of the syntax, like the create deep agent. There's a really simple function call that bootstraps the deep agent for you. It's just like create React agent, which is in LangGraph. And it's basically, if you're familiar with that, you've used that, it's just a simple LangGraph application you can build. It's growing, it's just brand new, but if you could look at this log scaled star history, it's taking off. If you look at it compared to LangChain, LangGraph, it's got pretty good growth trajectory. So people are jumping on this. maybe a little hard to see, and I totally stole this from your blog, Colin, which is fantastic on this topic.
Thanks.
But you basically have a list of tools, a prompt, which is called instructions here. You have sub-agents, which are optional. You don't have to use them if you don't want to. And then you can specify the model. And you just take those and just plug it into this create deep agent function, and then you get back those components that I discussed earlier, the planning tool, the file system, the system prompts for the sub-agents, and then you have a general purpose sub-agent that does some stuff under the hood. And you get back this LangGraph agent. Super simple from a UX perspective, a DX perspective. It's hard to beat. So the first tool is the planning tool. They basically took this from Claude Code. They basically reverse engineered this and built it into deep agents. And so this is what lets deep agents come up with a plan and then track that plan over a bunch of steps through a to-do list. And that's how it stays on track over like long executions. The second thing is the sub-agents, again, Claude Code. These are, subordinates that kind of have their own prompts, their own tools. Sal talked about context pollution. This is what helps avoid that with, context quarantine. So the main agent isn't flooded with stuff that it maybe doesn't care about. And then there's the sub-agent that I talked about earlier, the general purpose sub-agent. And this on the right is just like a simple example of making a sub-agent. You give it a name, a description, a prompt. Maybe it's using a different model than the main agent. And you just plug that in as one of the sub-agents for the create deep agent function. And then you have your system prompt. This is a built-in system prompt. So again, they took or reverse engineered Claude Code's system prompt, and they will not let you edit this. This is like part of deep agents. It is on the roadmap to let users tweak it, but right now it's like part of the package. You'd have to go edit the source code if you wanted to update this. And they say in the README, like, this is what makes this package good, basically. They say, like, this is how it works. Like, this is the secret. So basically, you as the user, you can only customize part of it via the instructions parameter or the prompt here. And this is just concatenated onto the rest of the system prompt from Claude Code that they reverse engineered. And then you have the virtual file system. Virtual file system is the state. And so it's built on a file system, but it's really a LangGraph state object. And it has files, things that track pieces of data. You can pass these as the user when you create the deep agent, or the sub-agents can actually create and edit these files. So it's a virtual file system, which means you could run a bunch of stuff in parallel. It's all in memory. You won't have like stuff writing over each other. So it scales very well. And then there's these built-in tools. It comes with 5 built-in tools, and these you can edit if you're feeling risky and you want to live on the edge. You can disable these or change these. But this is how the sub-agents will keep track of what they're doing. This is how the main agent knows what to do, delegate stuff. So you have a to-do list, which write to-dos function. You have write, read, ls, and edit file functions. And so you can imagine all these sub-agents in the main agent kind of editing a bunch of files, quick succession, and keeping track of state that way. It's pretty cool, I think. Okay, so I'm going to give a little demo, and this is a hard turn in this presentation. But the example I came up with was like, what's a good deep research use case? And this might not be a great one, but let's assume I'm a product manager and I want to do research about my products. So the question products managers are worried about as they do, who are our customers? What are their use cases? Are we solving their problems? What are we telling them about all this stuff in our outgoing marketing material? What are the customers telling us about in their social media? Just so happens I have a bunch of data on this, so this is perfect. So I'm going to go over here now, and can we see that? Is that big enough? Probably not. I zoomed in. It's probably fine. Okay, so this is how you would set up a deep agents project. You just I have this helper function. It basically just creates runs this create deep agent, and I'm passing it a model, and I'm passing it local tools, which is just a query tool to pull the data. And I have some prompts here. So I have a research instructions prompt, which is basically telling the, telling agent what it is. Like, hey, you're a researcher agent. You're looking at marketing material, et cetera. And then it has these sub-agent prompts. So I have 2 sub-agents here. One to look at the marketing material. That's the stuff that we're sending to the customers. And then one to look at the social media, which is what the customers are sending to us. And I'm asking both sub-agents to extract use cases and personas from the content. And then the main agent's going to look at both, and then imagine that Venn diagram again. It's going to say, what are we missing? What are we overlapping? And then it's going to give some recommendations as far as what mismatches there might be between what we're telling customers and what they're telling us. So, this is my fantasy product manager agent. I'll just show you the tool really quick. It's just it just runs some SQL queries. It's not very fancy, but then it runs some summarization, just some quick summarization. Get me the use cases, the user personas, the problems solved in this content. Just one sidetrack. Deep Agents doesn't by default surface a lot of observability when you're running it and you're reading the logs. So there's this handy post model hook parameter, and you can pass in whatever type of logger you want. I have this pretty verbose logger. I did see at first it would just run, and I was like, what is going on? I can't see, nothing's happening. And then I realized, I need to add this logger to really see what's happening behind the scenes. So I will show, I could run it. It takes a few minutes every time. I'll just run it over here. We can see how long it takes. But in the meantime, I'll show you. In this case, I'm saying, hey, look for Workers AI. I work at Cloudflare. Let's look at Workers AI. While that's running, I'll just show you what this looks like when it's running. This is kind of tough to zoom in. Basically, the first thing it does is it says, and I'm running this with Sonnet, this Claude Sonnet. The first thing it does is it writes the to-dos down that it needs to do. And then, these are the things that are going to get delegated to the sub-agents. So the first thing it says is extract the target product from the user's request. That was Workers AI, that's the product. And then it says the next steps are launch the marketing sub-agent, and then after that, launch the social media sub-agent. And then after that, compare the outputs from them. And then the last thing is provide the recommendations. So pretty simple use case. This is debatable if this is really a deep research use case. It's kind of on the edge. It's not that deep, but it does those things, and then it starts going off and running its different tasks. So you can see as it goes, it starts to track what it's doing. So now it's completed this first task. It's in progress with the second one. Keeps going. Now it's completed the second one and the third one, and now it's starting to compare the results from both of them. And then finally, it finishes everything, and it gives you a result back. And I should have asked this at the beginning, but who's used deep research before? I would hope a lot of people. It's pretty awesome. Every LLM as a service has it, like Perplexity, Claude, Google Gemini, they all have it. Basically, it gives you a giant report back. And so this is what it gave me back. I ran it a few times. So it says marketing versus social media analysis for Workers AI, overlapping use cases, personas, strong alignment, AI application development, surprise, right? That's pretty obvious. Serverless AI computing, edge AI processing, image processing, those are all overlapping. The personas that are overlapping, AI developers and engineers, that's pretty obvious. Startup founders, technical product managers, okay. And then what are the marketing materials overemphasize? Basically, threat intelligence. We talk a lot about that in the marketing docs. Not as represented in social media. Automated social media. We don't see that in the social data, but we advertise that more. We're talking mostly to CTOs and CISOs when we should be talking more to individual developers. and we're focused a lot on large enterprise, which is not as prevalent in social media data. So anyway, you can kind of get the gist of the report. It basically just describes that Venn diagram for you. Like, what are we overemphasizing? What are we underemphasizing? But it gave a pretty good result. I think it looked at, let me see how many social media posts, 500 random social media posts. And I don't know how many marketing materials it was. It was a lot, though. So did a pretty good job. And did this thing stop running? Let me see. Yeah, so it ran in 1 minute and 48 seconds. It's not always that fast. Sometimes it's a little slower. And the model does matter. I ran this with Sonnet, like I said. Opus took a lot longer. I haven't really compared the outputs, but I feel like Opus is probably higher quality. And I've run this probably like 10 times. I've seen a few times where it's just crappy quality, and I don't know why. And it's just the model, and I can't explain it. So I have a lot more testing to do, a lot more models to evaluate on, but I'm pretty impressed. It's a nice framework, easy to get started with. You just need a use case, and yeah, I recommend it. Check it out. The GitHub's really good documentation. Or check out Colin's blog. Colin's blog is even better. So. Let me go back to the PowerPoint, just so I could show this one slide.
Nice.
I made that in Google Slides, just like prompting inside. Yeah.
Wow.
Oh, nice.
So they're stepping their game up. Yes.
So is there, I'm assuming not since you had to build the logging, but is there any like mechanism built in for interrupts, or are you going to build it?
Yes, it is. They built a lot of that. Most of the I won't say most, but a lot of the LangChain, LangGraph features that you're already kind of familiar with are in this. So they note that in the README. They write human in the loop is there, MCP. You can have the MCP adapters in there. Here it is, human in the loop.
Put that in your prompt, like if you run into this situation, interrupt and ask for something like that.
That would be cool. I would love to test that. I'm sure it's possible because they show it in the docs. So yeah, tool. Okay, here you go. This is how you do it. Yeah.
That's from Linwood. Awesome. Well, thank you so much, Collier.
Yep.
I appreciate you running with the deep pages.
Yeah.
Oh, cool. So I think a lot of people here are further along than I am in AI engineering. So I came to my first AIMUG meeting 2 months ago, and I decided to just jump right in. So I have a history in data science and MLOps and doing developer advocate work. So I thought like the easiest thing to do would be to solve one of my own pain points. And I decided, well, I have a terribly messy desktop, and that's my idea for Rosie the robot. And you can follow me on X. That's the last of any marketing I want to do. So right now, my desktop has probably 2-3 years worth of just junk on it. The same is for all my directories. And I have like vague names, duplicates, random downloads, and oftentimes I have to actually click in order to find out what it is that I saved. So I can use like a deterministic method. I can use like clustering, sort of like k-means, things like that. But the problem is that they don't really pick a very intuitive naming scheme, and they don't structure it to how I would like it. So this is a bit different from like a specific like LangGraph technique talk. I did promise Collier that I would inject it. Sorry, Colin, I would inject it. So I'm just going to go through my sort of idea here, and I hope that by like next meeting it's going to be further along, and we can kind of grow together and see it at the very beginning and how it gets more sophisticated going on. So the solution I'm aiming for is that I have a maid. It asks a few questions. I give it a few answers. It proposes changes. I give it approval. And then it safely organizes my computer, tells me what it did, and then hopefully I don't have to rerun it again. So the current state is that it's right now just CLI. I have a SQLite event store, and it's LangGraph ready. I already have wired a few agents, or like put the precursor in there. The idea is that I'll have human in the loop, so there's going to be, so there's a planner, it scans everything, and then there is a reviewer that then comes and asks me or the user what it is that we want to keep, what do we want to name, sort a few things, and then lastly there's an executor that goes on and takes in both the algorithmic clustering information and also my own preferences, and we get the final result. So like I said before, most of you guys are a lot further along in the LangChain development than I am. So I'm going to be talking to anyone who's just starting out. And right now I'm doing sort of a live production. So instead of overbuilding before I get feedback, this is feedback. So there we go. So, and also have a definition of done. So I've said I want a clean desktop. That's my definition of done. So what I'm doing is I have one painful use case. It's messy. A first win, which is I'm going to have a CLI that's deterministic. So then we have clear definition of our problem. And we've already gotten started. I have a deterministic core. I'll be doing human in the loop gates on risky steps. And I will be demoing, well, it's probably not going to be 60 seconds, but I have a demo and it's short. And like I promised, so we're going to have LangGraph control flow for bounded loops, LangChain tools, and also these we're going to have traces and fixtures. So this is the checklist. I already said pain point. The metaphor is it's a robot. It's made for your computer. That's going to inform the UX and the prompts. The architecture is right now good for like an initial demo, and I'll build on it. I'll show you a roadmap of what I'm going to do later on. Eventually, I want it to be an EXE that people download, and someone who is not a developer can easily benefit from it. And then lastly, the demo. So the outcome, having a reviewable plan that groups related files and proposes a safe move with an undo, that's kind of informed the tools that I've made. So we have a file scan tool that walks through the directories, scans the whole directory for the files. We have an embeddings tool that has also fallbacks, so it's really HDB scan is the first one, and then I believe it goes to a different agglomerative clustering algorithm, and then later on we go to a simple cosine similarity, and the names for each cluster are TF-IDF. So then we have a tree shaper so that it keeps it sort of flat and doesn't go too deep. And I have some tools for checkpointing and file ops. So this is just quickly how the metaphor informs the prompts, so or the UX. So it doesn't immediately mutate. It has human in the loop. And this is sort of like over my head at this point. I haven't used Pydantic, so I'm kind of like at this point over my skis. So in the end, I'm really hoping that I'll get a lot of feedback here. And then this is an example of the plan view. And then finally, the architecture. I have an event store, and then use projections. Keep all of my agents in the agents directory. And then I have a core graph that's just a skeleton. It hasn't actually been fleshed out. And so first, it's just a dry run scan. This is going to be of my downloads folder, and it takes less than a minute, and it should come up with a list of clusters and a list of directories that it wishes to create, along with move plans for which files to move into those directories.
While it's running,
Mm-hmm.
what do you do clustering based on? Is it the titles or the contents, or?
Yes, so I haven't tested out fully the clustering algorithm. I have been, I went from having, it's kind of loud. I've been going from using OpenAI just to check my functions and document things to using Codex. So I really just trusted it on the algorithms part as far as clustering is concerned. But it assures me that, number one, it's using HDB scan, and then it's going to an agglomerative clustering, and then later a cosine similarity. So that's something I have to really go in, check manually, verify that it didn't BS me, and write some more documentation on that. But here it goes through, we get two tables. It has make directory, so create directory and move. And we have confidence levels, confidence levels. Some of these are actually hard-coded. So I think 0.6 is hard-coded in there. The confidence is also something that I haven't actually been able to get a straight answer on for the definition of how it's being calculated. So this would be used later on for the agents to determine whether or not they should actually go through with that or not. And then here's a list of the largest folders. This is just to show that it will not implement without a yes.
Can I ask a question?
Yes.
Did you say that 0.6 was hard-coded?
It is.
What do you mean by that?
Some steps and some, it also said when I asked specifically about this. So I was querying okay, here, what did you implement? Okay, what is confidence? Okay, I got planning to use that later on for the agents to determine whether or not to go forward and implement that step. I asked, okay, well, how do you calculate it? It says, well, right now I just said, well, when we do this particular scan, we're just going to hard code and say that we have a confidence of 0.6. So that's all it is. It's just a magic value at this point. And then this one, we have, so it just creates a directory and then it undoes it. And the point here is that I'm using Windows operations to then go into, when it deletes anything, it goes into the recycle bin. And the last one is sort of a dev cleanup. So this one searches for just any sort of common caches that we might have. This is the virtual environment, and you can delete that too if you wanted, and it would end up in your recycle bin. So this is very early on, and this is sort of my promise to include LangChain, LangGraph. I haven't looked into this, so I'm going to get a lot of feedback. I've seen some people scrunch up their eyebrows, and so I think that they have some things to suggest, some advice to give on my approach. So I'm just going to show the roadmap for this project, and I would take any sort of suggestions, questions at this point, and we can go from there. We've got 3 minutes, so 3 minutes of questions or comments or so. And here's a question. So is anyone building anything end to end, or are we as far as like a complete application to hand off to someone else? Are we focusing more on internal dev tooling? Yeah.
So when you were talking about when you're asking it how it's calculating, you did that a couple times. Do you do that in a prompt too? Or how
Oh, so yes. So let me grab that. I actually have an answer for you there. So, like I said, this is my first time using Codex, and like you said yesterday on the call, with AI things have gotten pretty fast, and so you end up going faster than you would like. So I would like to answer your question regarding confidence, and so right now I'm not sure. Right now, so confidence is how sure the algorithm is about the proposed action's correctness. So a classification, an assignment confidence. And so the calculation today, so for the rules-based classification, it's defaulting to 0.75. So that's not what we're doing.
I'm more interested in how are you getting this output, right? How are you interacting to say, right? Because you're saying it has an explanation for it, but it's not very deterministic or whatever. So how are you interacting with it and getting knowing? How do you even know what it's doing to begin with?
Oh,
The whole system. Where are your prompts? Did you show that?
so it's not prompting. It's all deterministic. There's really no LLM in here at all.
Okay.
The only LLM involved is in the writing of the code. So yes. So right now, all the functions are deterministic.
Okay.
So the idea here is to give a deterministic core architecture and then add LLM into it, and then give it the controls to then make decisions later on.
Gotcha. Okay. Cool. You got the structure in place.
Yes, so I'm hoping that this will be a lot more relevant to the LLM, LangChain, LangGraph group once I actually put LangGraph and LangChain in it. So.
Yeah. Maybe people can help.
Yeah, just one quick comment that I think is really cool about this is that like we're all coming from this place of, not all of us, but I know I am coming from a place of just using LLMs for everything, and you're using the tooling around the LLMs, but you're plugging in the traditional data science algorithm, like your clustering algorithm. You're plugging. So I don't know. I think it's just really interesting bringing the two together.
Yes, so like I was talking earlier on that when I was in data science, I kind of figured I would go back and just do a lot of that, and then found out that a lot of the sort of like classification of text, like semantic analysis and all of that, kind of gotten taken over by LLMs. I was like, oh. So I was trying to like re-implement things that have been superseded. And so this is really, me diving in, feet first or head first into AI engineering.
Awesome. Well, thank you so much, James, for sharing that with us.
Thank you.
Really appreciate the different perspectives from the data science.
All right, so I think I have everybody here. Do we have, hopefully not too much echo, you can hear me. My dashboard, I gotta confess, that is some sort of Windows XP looking dashboard. I can't compete with that. Modern
Web technology is not quite there. All right, so we have my slides up here. I'm going to talk a little bit about something called Streamlit. Now, who here has used Streamlit before? Okay, so everybody. Well, okay, I shouldn't say everybody. A little over half the room. So this is a beginner talk about Streamlit, right? So I want to introduce Streamlit to people who have never heard of it. Maybe there aren't even Python programmers. I'm going to show a little bit about dashboards, a little bit about data cleaning, not too much. And then I'll show you how to actually use an LLM with Streamlit so you can chat with your data. Now, I've got some people in here that are probably a much bigger Streamlit expert than I am personally. So if you see something here and you're like, want to chime in and be like, ha, there's this really cool way of doing it they just added in version 0.49, feel free, okay? So without any further ado, this is Streamlit. So let me just show you what we're building. And all of this is shared. I have links at the end to a GitHub repo. And there we are, assuming it doesn't crash. So this is the National Park Visitors Dashboard. This is a live demonstration. Let me make this a little bigger on the screen here. So yeah, that's ugly, but you can see it readable. This is an interactive dashboard. For those of you who have worked with Jupyter notebooks, for those of you who have worked with React applications, Flask applications for doing a little bit of data analysis or data presentation, this is kind of the middle between those two, right? So we have this idea of, Jupyter notebooks. We can log in, we can show some stuff, we can click the run in the cell, it goes through, it shows some charts. It's cool, it's interactive, you type into it, that's great. There's another side of things, right? We could build a whole React application that has interactive charts, has fetching of data from an API, it's real slick, no limits, but it takes a while to build. That said, of course, we could just have Claude or any of these other tools just kind of take our CSV file and build us a nice React dashboard out of it. But Streamlit's kind of that thing in the middle, right? Streamlit's what you want to use for like a prototype, for user experience testing. You want to do something that involves like an internal tool. Now, would I personally build like a SaaS on top of this? No, I'm sure probably somebody has, but this is not where you go for this, right? This is much more think like prototyping, internal tools, something you can share with people internally. That's where we want to go with this. So I took some open data. It's the visitation for our national park system. And I've got links to all that. And just made a really simple dashboard out of it, right? So I can come over here and pick a year out of this. And I can see the visitor counts in 2007. Yeah, it's a little hard to read just with this. But I've got 37 national parks, whatever it is these days. Personal goal of mine is to actually visit all, like I said, 450, whatever it is, units of the national park system. I'm up to about 300 and something of those, which is a sizable chunk. Most of the rest are really hard to get to. They tend to be very remote. But you can see that the largest over here, the visitor count, it's going to be Blue Ridge Parkway, which is it's effectively a highway, and so it's going to have a pretty big count. Some of the ones on the right-hand side, they're just not open very often. They're seasonal, they're out of the way. They don't have very high visitation. So we can see that with the chart here. We can see a table with the data, right? So we've got a table we can go through. And again, for those of you that are familiar with like the Jupyter notebook, the Pandas data frame, this is just another way of working with data frames and showing tables, right? So we've got all that. And then the cool thing I want to show off is, let's just make sure this works. I can actually start to chat with this dashboard, right? So I can say, what was the most visited park? And this is the part where we're actually using LangChain. Now, let's see if that actually works. OK, so chat with my data down here. It's thinking, and it's actually chatted with the data, right? So it says Blue Ridge Parkway, 17,000, or 17 million rather. That's the right number, I would assume. What's cool is over here, I had filtered the amount of data from like the year 2005 to the year 2007. My Streamlit dashboard figured that out. Again, for all of you that are Python whizzes, this is a data frame, typical Pandas data frame. And I filtered it down based on the selection over here, the year, and I could even filter by park and drop some of these parks out if I wanted to. And it passed that chunk, basically the data frame as a CSV, as into the prompt. So very simple integration. Not your production class integration, right? Because this could use this could use a decent chunk of your context. But if you're working with a data set where you can filter and that reasonably falls into like a context limit, this is a lot simpler than setting up MCP or RAG or anything like that, right? Again, we're thinking prototype here. We're thinking internal tool, right? It may not make sense to completely productionize this tool right away. All right, so hopefully that covers what this is. Let me talk a little bit about how to build it. I don't want to read all of these slides out to you because a lot of it's, quite frankly, it's a bunch of Python code about data cleaning. But I do want to cover the tools that I use to build it. Got Streamlit. That's the key technology here. What makes the web framework very, how should I say, interactive without a lot of work on my end. We're using pandas for the data wrangling, right? So again, typical Python data science, data exploration, data analysis. But you could use almost anything else that's data frame compatible, right? So there's a Python standard, I don't know, I can't remember the name off the top of my head, but there's like a data frame API that they're all basically compatible with. And I'm using Altair for charts, LangChain, of course, for LLM integration, and then it's got a little sidebar nav for a multi-page field. Here's the sample data set. So it turns out that when I downloaded this from the National Park Service, it was in a wide format, so I had columns for the years. That's great, but it doesn't lend itself well to this sort of analysis. So I used Melt to convert that to a long format. So pretty cool stuff. Here's just a rough data cleaning overview. I took the raw CSV file. I dropped the average column out of it because it actually gave me the average for like each year. I didn't really want that. I can calculate that myself if I need it. I dropped the empty year columns because the data wasn't completely clean. So there was also some weird columns in the middle that had no data. I don't know how it got in there. I used Melt to reshape it, which was just kind of a cool little quirk. Filled in anything that didn't have data, converted the types, and ended up with the final data frame. So again, I could kind of go through this if people are curious about the pandas and the data framework, but it's all just sort of, here, there's my data cleaning, transforming from wide to long. I used Melt. I did a little bit more cleaning here. Set some sidebar filters. So this is really your Streamlit stuff. The part before that was just straight up data wrangling. I've got my data cleaning. I've got my pandas data frames. This is where we're starting to get into Streamlit, right? And one thing I should show you is the code for this. While it's not necessarily the cleanest, I stuck everything into one app.py file, right? So if I just make this a little bit bigger, I've got everything in one app.py file. Again, thinking about this, you could organize this differently, right? But we're thinking prototype, we're thinking internal tool. And this whole thing is 126 lines of code, right? Now, if you all try to build this out in React or something, talking to a backend, fetching some data, it's gonna be a lot more than 126 lines of code. I think we all know that. No shade against React, right? Just this keeps it simple, and I don't know what Streamlit's necessarily doing under the hood, but I can just declare like I've got a text input, and it just reads out of it, and it's reactive. It's very nice. So just going through this as well, you can see that all the lines that I've got here, I've got the page set up. That's important. I've got the sidebar navigation set up, pulling in the data. And again, I don't have to do data clean on every single load, right? I could do some caching in here, but again, it's an exploration. The cool thing is that I've got multiple I've got multiple pages. So if I come back here, I can switch over to like park trends over time and see like different type of data than maybe the dashboard overview. I've got some key performance indicators here. So I'm pulling out the total visitors in 2005, the most visited park. Again, that's all interactive. If I switch this to 2010, I'll get the total visitors in 2010. So all very cool stuff. Just kind of coming back here, bar charts, KPI metrics, a couple things you can do. Here's how you add navigation with sidebar. Again, I got a sidebar. I got one line of code to configure a sidebar. So just everything in this is very concise, very terse, and very easy. So I like it. I've got a line chart here using Altair. And again, just passing in a data frame. I'm selecting a series out of a data frame and passing it in and getting a chart out of it. And you don't have to use Altair. You can use pretty much anything else. All right, LangChain. How's that fit in? And again, you might be thinking to yourself, OK, I've got to integrate some chat component. I've got to bring in some JavaScript code to get that chat to like work out cleanly. I don't need to. This is just regular Python code. I can bring in LangChain itself. We've all heard about LangChain today, so I don't know that I need to introduce it again. But I'm using it for this chat with your CSV feature. And I'm not using a RAG, not using a vector store, just using a live filtered CSV data. Just again, want to be clear, consider your context size, your token limits, and your pricing here. Again, depending on what you're building, it's a prototype. You're not going to go over the limits, but be conscious. LangChain integration can be easier. I'm pulling in chat OpenAI's here, setting the temperature to 1. So that's all GPT-5 Mini apparently supports, and that's using 5 Mini. Here's how the data flows, right? So I've got the user putting a query into chat. That goes through Streamlit. It builds the prompt with a query, filters the data frame, passes that all through LangChain to the LLM, and it comes all the way back, right? So what does that actually look like in practice? It's this Python code right here. And again, up at the top, I'm pulling in filtered_df. That's my filtered data frame based on the radio buttons and the filters that I set up in the sidebar in Streamlit. Converting that to a CSV, and then just dumping in a very simple prompt. You are a helpful assistant. Of course, it'll answer other questions, but that's where the world of guardrails comes in, which is something completely different presentation than this. So we're filling in the context, we're filling in the query, and that's about it. So this is how you invoke that using LangChain. And again, we're not doing streaming, we're not doing anything fancy. We're just doing a very simple chat completion. All right, so to keep this on wraps, I didn't want to go all the way into a whole bunch of different things, but we could use retrieval augmented generation, or RAG, to selectively include data. We could use model context protocol, which a few other people have talked about, to go out and maybe like talk to an API to get this data. Just depending on if we want the LLM to ask for specific information. So if we ask the LLM, okay, what were the top visitors in 2007, instead of passing the data along, the LLM would respond back with, okay, tell me what it is, and then I'll come up with the response. For all of you, if you wanted to try this out, try your own data set, try a different LLM, try a different model, just something to try out. And then also think about guardrails and observability. So you could use something like Langsmith to do some observability and check to see what chat messages are going through. And then again, if you were to actually deploy this, think about guardrails here, because you don't want some situation where someone's chatting with this thing and asking weird stuff, right? Make sure it stays on track. Just some optional stuff you could include: upload your own CSV. Again, how much code is it to upload a CSV into context? With Streamlit, it's not much. You can deploy it to the web. I'm not going to send the LLM version over to the web because I don't feel like running through all of my token limits or whatever, but here it is running on the community version of Streamlit. So this is just a public GitHub repo deployed to Streamlit Cloud. Cost me nothing to run. It fell asleep since the last time I worked on it, but popped it back up, and this is just about as live as you can get, all interactive and so forth. All right. Some ideas here if you want. Just consider data privacy, and follow the Streamlit tutorial. I've got a link here. Integrate an LLM yourself into that for the Uber data. Create a hobby data set and chat with it like your collectible collection. And then last, just to wrap things up, we've got an interactive dashboard in Python. I've got some code for all of you. Got the slides. I'll figure out a way to share it through the chat. We brought an LLM chat into the application. And again, the chat components are built into Streamlit. So I didn't do anything to get that chat to work. Like, it's built into Streamlit. Super simple. And quite frankly, I just kind of went through their tutorial and modified just a little bit to work with LangChain, but not a big deal. Streamlit's great for prototypes, faster to build. Find your own data set. I've got some docs up here for Streamlit. I've got their chat with an LLM documentation, which kind of covers the chat side of things. Using OpenAI with LangChain and Python. If you're new to LangChain, that's a good way just to get started with the OpenAI API. You can find me at jefflinwood.com. That's my email address if you want to email me instead. And that's my open source project, which has nothing to do with this. It's not even in Python. And then last, this repo's up on my personal GitHub. It's public. This stuff's in a branch. All right, I think that should cover it. Anyone have any questions?
Questions? I have a comment. You know,
Sure.
we were playing with Streamlit about probably 2 years ago when we were trying to figure out like what the hell is this AI stuff. Well, our first labs were Streamlit. We basically hacked Google. Gosh, my brain just went. Excuse me. We're running notebooks on Google.
Oh, sure, yeah.
And using Streamlit to interact with their data, and it did not look as beautiful as this.
No, it's some really nice stuff.
Yeah, like I'm really impressed.
I have not met a back-end engineer that does not fall in love with Streamlit.
Right. Drop those front-end developers, just like, you know, kind of pull them out of the chain. I mean, again, just to get a simple project up, right? You know, we're not talking about something you'd actually deploy, right? We're just talking about a prototype.
I mean, it's simple and effective.
Yeah, absolutely.
It's really great. Well, thank you so much, Jeff.
Sure.
Thank you so much. And Jeff, James, Collier, Sal, thank you so much for taking the time for this. I know it's a lot of work. Can you switch over to 3 real quick? 3 for my whatever. 4. Yeah, there we go. So we're going to go ahead and wrap up here. If we can throw our trash away, straighten things up. We're going to wrap up some cables and whatnot, and then we're going to walk right around the corner to the tavern for an after party. And thank you so much for joining us for Austin LangChain, and we'll see you soon.